for parallelograms. We're going to prove and apply properties for rectangles and octopuses. Nope. Use the properties of rectangles and rhombi. That's going to really bother me. To solve problems, and we're going to prove that a given quadrilateral is a rectangle or a rhombus. Okay, so another type of special quadrilateral is a rectangle. A rectangle is going to be a quadrilateral with 4 right angles. Interior. Now, if you think about that, if they're 90 and 90, then, and we have alternate, yeah, so they're going to have to like also be parallel, right? It has to also be a parallelogram. Okay. Okay. If we have a quadrilateral that is a rectangle, then it is also a parallelogram. Okay, that's really fun. If a parallelogram is a rectangle, then its diagonals are congruent. Would you make sure you have your little blue sheet out for this, please and thank you? If you don't have it already, would you get out your blue tree? Okay, so let's say that we have a rectangular picture frame with JK being 50 centimeters and JL is 86. Here, let me do that in another color. Okay, so now we have to find HM.
My initials. Here, let me count. HM? Wouldn't H must be half of 86? Because
Yeah. Okay, so as if it's a rectangle, which this says that it is, we know that something is special about its diagonals. Its diagonals are congruent, right?
Yes.
Okay, so we know that KM is also 86. Centimeters, so HM has to be half of that, which is what you said. Okay, so what is half of 86?
43.
Okay.
42.
Thank you. So the reason that worked is because a rectangle is a parallelogram, and we learned on our parallelogram day that the diagonals of a parallelogram bisect each other. Okay, moving on. Okay, so here we have a cute little rectangular gate with diagonal braces. We have to find HJ and HK. So HJ is this one, and HK is that one. Okay, so we know the gate is a rectangle. So if this is 30.8, this one is also 30.8. Okay, so this entire thing has to be congruent to that entire thing. So I can say that my HK is 2 times 30.8, which would be, oh my gosh, help me, 61.6. Is that right? Inches. You guys have the calculators, not me. My mental math is notoriously bad. Okay, so that's HK. We still have to find HJ. Any ideas?
That one's 48. Or no, it's not. I was looking at GK.
Well, I don't disagree with you. If GK is 48, what does HJ have to be? 48. So I agree. Because opposite sides have to be congruent. Okay.
What was HK? 61.
We don't really know because none of you have checked me on a calculator. So this is my best guess. All right, here we go. A rhombus. A rhombus. Okay. A rhombus is another special quadrilateral. A rhombus is a quadrilateral with 4 congruent sides. Okay, so I know you guys love my little. Okay, here's a square. Now it's a rhombus. Here's a square. Now it's a rhombus. Actually, a square is a special type of rhombus. It's also a rectangle, right? Okay, so we know that if a quadrilateral is a rhombus, then it is also a parallelogram. Okay? If a parallelogram is a rhombus, then its diagonals are perpendicular. Okay? If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. Okay, so look at this. Okay, so what it's saying is that when we have a rhombus, the diagonals are perpendicular bisectors. Hey guys, perpendicular bisectors of these angles. So these are congruent, these are congruent. Let me do 2 arcs on this. These are congruent, and so on. I don't know if I'm having room. Okay, that looks just crazy.
Oh my gosh, yeah, I'm not writing that.
Okay. All right, let's try some problems. Okay, like a rectangle, a rhombus is a parallelogram. So you can apply the properties of parallelograms to rhombi. Okay, so we know that this little figure is a rhombus, so we have to find TV and the measure of angle VTZ. So TV is this one, and the measure of angle VTZ is this little guy. We're going to start with the B's. Okay, so a rhombus is a parallelogram. What do we know about the opposite sides of parallelograms? Check your tree. They're parallel, but they're also congruent. So I know that that side has to equal that side. So I can write the equation 3, or let's do 13b minus 9 equals 3b plus 4. Okay, now I can subtract away my 3b from both sides and get 10b minus 9 equals 4. Add 9 to both sides. What's that, 13? So 3b, sorry, wait, what? I think I got 10b. 10b is 13, right? Okay. Divide both sides by 10, and I get B is 13 over 10. Okay, so what do we know about the sides of, hey, what do we know about the sides of a rhombus? They're congruent. They're all congruent. So the fact that this was a parallelogram allowed us to solve for B, okay? But now we can say, okay, well, it's also a rhombus. So these sides also are congruent.
Yes.
Okay. So we can plug that B in and find TV. Do you want to plug? Ew, gross. Did we do that right? All right, let's just do it on the calculator. Do you want to use this 3B plus 4 or 13B minus 9?
3B plus 4.
Okay, let's plug that in. So our measure of segment TV is 3 times 13 over 10, gross, plus 4. I definitely can't do that in my head, so I need your help.
Yeah, you got it.
No.
What is decimal 13
Okay. Okay. Yeah, they're 90. So if we know that the diagonals of a rhombus are perpendicular, we can say, okay, this one right here is 90. So can we solve for A if we know that that little angle is 90?
Yeah.
Yeah. So we can just say, okay, 14A plus 20 is 90. Subtract away 20 from both sides. We get 14A is 70.
That's
Is it really?
Yeah.
Okay. Okay, now what do we do with the A?
put it in.
Yeah.
Plug it in.
Yeah.
We can plug it in. So we also know that the diagonals are the angle bisectors for these cute little angles right here, right? So if I can find this one, I know it's little buddy because those should be congruent.
Right.
Okay, so I'm going to take the 5, I'm going to plug it in.
It equals
5 times 5. What?
What are you doing?
What are you doing?
Oh, I'm doing different thing. My bad. Don't listen
Okay.
to me.
So I'm getting 20.
Yep.
So the measure of angle VTZ is 20 degrees. Okay, that was exciting. I think we got the hang of it now. Okay, so we've got another rhombus. God help us. Okay. We have to find the measure of angle GCH if the measure of angle GCD is B plus 3. Let's label. GCD, okay, so that's this whole thing, is B plus 3 degrees. And the measure of CDF, is 6B minus 40 degrees. Oh, and we also have to find CD. Okay. What do you guys want to do first, the angles or the side?
Angles.
Okay, so look at your blue tree. What do we know about consecutive angles in a parallelogram?
Congruent.
No,
Perpendicular.
no.
Well, those are good.
A rhombus is a parallelogram, so we're allowed to use all of our parallelogram stuff. Okay, look at your blue sheet. Everybody look at your blue sheet. Consecutive angles in a parallelogram are supplementary, so they must add up to 180 degrees. So I know my B plus my 3 plus 6B minus 40 have to all add up to 180. Okay, so that gives me 7B minus 37 is 180. So add 37 to 180.
It's 31.
What did I do wrong? What was 180 plus 37?
217.
Excuse me. I'm choking on nothing. So when you divided it, you say you got 31?
Yeah.
Okay. So now we can plug that in. We want to find GCH. GCH. Okay, well that's just this little bitty baby one. Okay, so can we take our 31, plug it in for this expression, and then we'll just chop that in half? Okay. So the measure of angle GCD is B plus 3, which is 31 plus 3, which is 34 degrees. And then we'll just take that in half. So the measure of angle.
Wait, where am I taking it?
What?
Oh, that's CD, my bad. No?
GCH is half of GCD,
Oh,
right?
yeah.
34 divided by 2 is 7.
I'm also getting 17. GCH is 17. Okay, that'll do it for the angle. Okay, now we still have to find CD. Okay, CD is this guy. Any ideas? Can you put your phone away
Would it be
and like leave it away so that I don't have to keep saying it?
would it be B plus 3 equals 98?
Okay, so right now we're working on sides.
Yeah.
We're switching gears. What do we know about the sides of a rhombus?
They're all congruent.
They're all congruent. So I don't know anything about this side here, but I know these two, but they're the same as that one.
Right.
So it's like I know that one. I might as well. So if these two are congruent, can't I just set them equal to each other?
Yeah.
Okay, let's do that. 5a equals 3a plus 17. Subtract 3a from both sides, and I get 2a equals 17. A is 8.5. And now we got to plug it in. Which one do you want to plug it into? It doesn't matter. Okay, so CD is equal to 5 times 8.5, which is, what is it? 42.5. Okay. Okay. I like that one better than the last one. Whew.
Wait. Why are notes so long?
Well, actually, not this one. This one. The other ones are longer.
Wait.
So when we have a parallelogram with certain properties, we can use the theorems to determine whether the parallelogram is a rectangle. So these are those conditions that you have on your blue sheet. Conditions for a rectangle would be if we know that if we already have that it's a parallelogram, okay, and then we know that even one of the angles is a right angle, then we know it's a rectangle because all of them will have to be right angles. Because if you think about it, if we know that this is a parallelogram and these opposite sides are parallel, okay, then we know that same side interior angles have to add up to 180. So if this one's 90, that one's 90, right? And then if we shift our focus where, woo, what did I just do? I don't know what I did. Where these are our parallel lines, okay, and this is our transversal. Okay, same thing. If we have same side interior angles, they have to be supplementary. So if that one's 90, that one's 90, right? Okay, so that's why. And then we can work our way around the rectangle like that. If the diagonals of a parallelogram are congruent, then we know that the parallelogram is a rectangle. Okay, so if we already know it's a parallelogram and then we can determine that the diagonals are congruent to each other, then we can say that it's a rectangle. Okay, why does it say rhombuses? Is that just me? I feel like it should be rhombi. I don't know. That came out of a textbook though, so I'm not feeling as confident about like crossing it out and putting I. Whatever.
No, that's true. Rhombi is the plural.
Yeah, why does it say rhombuses?
That'd be like saying alumnuses.
Right.
It's alumni.
Yeah. Octopi.
Yes.
Yeah. Okay. If one pair of consecutive sides of a parallelogram are congruent, then we have a rhombus. Right? Because opposite sides are congruent. So if I can get these two congruent, then I know boom, 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 they're all congruent. Okay? If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. If one diagonal of a parallelogram bisects a pair of opposite angles, then we have a rhombus. Okay, wow. I feel like we're just going to have to practice those.
Oh no. Why?
Okay, so we have to determine if the conclusion is valid, and if not, we have to tell what additional information we need to make it valid. So if we are given that EF is congruent to FG, let's mark that. EF is congruent to FG. And we know that EG is perpendicular to FG. EG perpendicular to FG. What? FH, sorry.
Oh.
EG
Yeah.
and
Because of bisects.
FH. Oh, yeah. Thank you. I was really trying to make it. Okay. Okay. Look at your sheet. Where'd it go? I don't know. I got hungry.
Are they all right angles?
Does it say that? Oh, yeah. Okay,
Yeah.
yes.
Is implied.
Yeah, I understand what you mean. I thought you were talking about these. So you want me to do this.
They're all congruent.
Do we know that?
Yes.
How?
Because it would
They're all
be
in the same like.
it would be like the angles, like side, same side.
You explain what you mean.
Okay, so FG could really be congruent to EH because, like, they have like the same sides. And like, you could like.
So the point was that we don't know how long EH and GH are, that we could actually just have a kite here. Sorry, I'm repeating that for the video because I had paused it to give us time to think. So do we know that this is a rhombus? We don't. So what other information do we need to say that this is a rhombus?
Diagonal bisect angles. All sides are congruent. Two different things. No,
EH and GH. Well,
like they're congruent to themselves. Like they're not the same length, but like they're still congruent to themselves.
okay.
You know what I'm saying?
No.
No.
So we only have what's in pink, right?
Yeah.
But what we need is like also this.
That's what I was saying.
Okay. So we need.
Yes. Yes. Are you sure? Yes.
Actually, we wouldn't even have to have this one marked. If we had opposite sides, like that would be enough. But we can just say we need all four sides congruent. Yes. So this is not a valid conclusion. Okay, alternatively, if we had the stuff in pink, right, we could also have this, like those marked as congruent, and that would also do it. Because that would prevent this angle from being small and this one from being huge. Do you see why that would work?
Yeah.
Okay. So we either need the orange tick marks or the little blue angle congruent marks. Okay. Let's do the next one because that one was so much fun. Are we almost done? Okay. Is this the last page?
Yes.
Okay, we're gonna make it. We're gonna make it. Okay, so we have to determine if this conclusion is valid, and if not, we have to tell what additional information is needed to make it valid. So we know that ABC is a right angle. ABC. So is this a rectangle?
Yes. No. I don't.
We had a little blurb that said, okay, well, if we have one right angle that was interior, then we would know that it was a rectangle. But what was our starting condition? What did we already have to know about the figure? Look back in your notes. I'll go back with you. No, I went too far.
Is it the diagonals of the parallelogram? Am I not working with parallelogram? Where are you?
I'm lost. Okay, conditions for a rectangle. Okay, so they're trying to trick us into like saying this, right? Because we remember this picture where we just had the one right angle, right? But the condition also has to be that we have what kind of figure to start with? A parallelogram. So we have to already know it's a parallelogram, and then we can use the thing about the one right angle. Does that make sense? Okay. let's go back to our picture. Do we know that this is a parallelogram yet?
No.
Correct. So we would have to know that ABCD is a parallelogram first before this can be a valid conclusion. Does that make sense to everybody?
Yes.
Okay, so we're going to say not valid because we need to know that A, B, C, D is a parallelogram first. Okay. That one was easy.
No, I wasn't.
You're not done? Okay.
You're good.
Are you sure?
Yeah, I have it.
Okay. Okay, so now we have to use our diagonals to determine whether a parallelogram with the given vertices is a rectangle or a rhombus. Okay, so what do we know about the diagonals of a rectangle compared to the diagonals of a rhombus? Use your blue sheet.
Um, oh, rhombus has the diagonals actually opposite.
Hmm?
But everything else is. And also it uses perpendicular one.
Okay, yeah, so the diagonals for a rectangle are congruent, right? And the diagonals for a rhombus are perpendicular. Okay, that's what our blue sheets say. So let's figure out what's going on with these. Okay, so -1, 4, that's P. Q is at 2, 6. R is at 6, 0. S is at 3, -2. Okay. So we are looking for, are these diagonals congruent or perpendicular?
Maybe both.
If it's both, it's a square. Okay, so these are the diagonals. How do we find, we see that those are not perpendicular, right? Look at the slopes. Okay, so we know that it's not a rhombus. So we just have to show that these are congruent, and then we can say it's a rectangle. Okay, so let's use the little trick that we were doing on Friday with the triangles. So I have a leg of 4 and a leg of 1, 2, 3, 4, 5, 6, 7. Did I count that out right? Okay, so 4 squared plus 7 squared equals our c squared, which is our diagonal squared. What is 49 plus 16?
75.
Okay, sounds good. Okay, we don't want squared, we want just regular c. So we have to undo the squaring with square root. We will have 65.
Yeah, I did
Okay. You guys see, I will just write down anything. That's why the calculators are so important. So we'll have 2 solutions that make this true, but because we're talking about a length, we only want the positive one. So it's just going to be the positive square root of 65 or the principal root. Are there any perfect square factors hiding in 65?
No. Wait. Why?
It's not a perfect square. I can't think of any.
No,
I think we're done. So we just have to show that this other diagonal is also root 65 and we're good. All right, so Where's my picture at?
Why don't you just do the P to R, right?
It's like this right here. It's really weird. Okay, 1 and then 1, 2, 3, 4, 5, 6, 7, 8. It's going to be root 65. Okay, 1 squared plus 8 squared equals RC squared. 1 squared is 1. 8 squared is 64. I'm getting 65 again. When I take the square root, I get 2 answers. I just want the positive one. So root 65 again for the C. So those are actually congruent. So what do you think, guys? Rectangle or rhombus?
Rectangle.
Rectangle. All right, last one. We made it all this way. Okay, W is at 0, 1. X is at 4, 2. Y is at 3, negative 2. 3, negative 2. Hold on. Look away, look away. Okay. And Z is at negative 1, negative 3.
Why are you doing 2 X's?
Whoops.
If Y.
You're correct. Do you ever just like...
It's weird. It's a rhombus. It's a rhombus. That's why. If you draw your little in the interior.
Okay, so this one's Z. Okay, so let's connect up his little sides. But what we're really interested in are the diagonals. So if we want to show that these are perpendicular, we want to show that they are opposite what?
Opposite. Oh, that's it. Okay.
Mm-hmm.
I said a lot.
I'm agreeing with you. Okay, so let's find some slopes, right? So going from W to Y, it looks like I'm going down 3, right 3. No, you guys are doing it. Down 3, right 3, that is negative 1 for that M. And then for my other one, it looks like I'm going up however many and right however many. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 over 5 is 1. And the test for opposite reciprocals is that when you multiply them together, you should get negative 1. So if I do 1 times negative 1, do I get negative 1? Yes. So these are opposite reciprocals. Okay, so these diagonals are perpendicular. So what kind of figure is this? Yes. Are perpendicular. This is a rhombus. Diagonally. Okay, that's it.